All right, welcome back. Let's do this example here. So let's say we've got a situation where we've got some data, right? And we want to create a model for, create a linear function to model data. And the data that we're given is based on, let's say, a randomly selected 8 people, 8 adults of different ages. And we want to create a linear model for the data. Okay, so in this case here, we just want to have something that relates age and the systolic blood pressure measured in milligrams of mercury. So that's what I have here. So age and systolic blood pressure. Okay, so what they gave us was they gave us 2 of the points, and they want us to use the 2 points out of the data to create this model. So that's what we're going to do. So the first thing we want to do is calculate the slope, right? So we want to find systolic blood pressure. Let's say systolic blood pressure, we'll call it, let's call it S of X. So systolic blood pressure based on X, which X would be years, right? So we'll use function notation, X and S of X. And so now we want to find where mx plus b, right? We want to find the slope and the y-intercept, okay? So the first thing we need to do is find the slope. So let's find the slope based on the 2 points. So we'll do y2 minus y1. So again, it doesn't matter which one we start with. So let's do this one minus this one. So 118 minus 130. And then this one minus this one, which would be 21 minus 51. And so what do we get? We get a negative 12 over negative 30. Which gives us positive. And so what do we get? We get 2/5. Right? So what does this mean? This means that for every 5 years, the systolic blood pressure is going to go up by 2 milligrams of mercury on average. Okay? So remember, units Y, right? So milligrams of mercury divided by year. Okay, or you can look at it for every, another way of interpreting this is for every year that somebody ages, their systolic blood pressure will increase by 0.4 milligrams of mercury on average. Okay, so that's the slope and how we interpret the slope. And now let's continue. So we've got S of X equals 2/5 X plus B. And now we're going to use one of the points. It doesn't matter which point. So let's use this point here. And let's plug in our values to find B. Right? So in this case here, we get 118 equals 2/5 times 21 plus B. And so let's simplify this. So we get 41/5, right? No, 42/5. So we get 42/5. 42/5 is 8.4. So 8.4, so we get 118 equals 8.4, right? So if we take 42 divided by 10, that's 4.2. If we double it, that would be the same as dividing 42 by 5. So we get 8.4. So 8.4 plus b. Now, all we're going to do is subtract 8.4 from each side, and so we get b equals what? 109.6. All right, so our final model is s of x equals 2/5 x plus 109.6. All right. Now we want to use this model to say, okay, let's predict or estimate what the systolic blood pressure would be if we had someone that was 55 years old. So we want to find S of 55. So we're going to take 2/5 times 55 plus 109.6. And so now this is going to give us what? It's going to give us 22 plus 109.6. And so this is going to give us 131.6 milligrams of mercury. So that is the systolic blood pressure for a 55-year-old. So that's what we're gonna predict using our model, right? So we would say that somebody that's 55 years old, based on this model, is going to have a systolic blood pressure of 131.6 milligrams of mercury. All right. That's it. Have a great day.